Hi students, welcome to my channel. Last class we discussed about Young's double slit experiment. In Young's double slit experiment, what will happen? At the we are going to take the two coherent sources, the two light waves from the two coherent sources. What they are going to be interfere on this. They are going to take the alternative bright and dark fringes on the screen. No, yes, an alternative bright and dark fringes on the screen. Now, alternative bright and dark fringes on the screen is, for example, I am going to take this is the screen. At the center of the screen, we will get the bright fringe. Above the screen, what will happen? We will get the dark fringes. Yes, above the screen or below the screen, what will happen? We will get the alternative bright and dark fringes. Yes, like this way, what will happen? We will get the dark fringes. At the center, we will get bright fringes. Yes, center we will get the bright fringes. Yes, sir. Last class we discussed about Young's double slit experiment. Yes, Young's double slit experiment. Now, today's class we can derive the expression for fringe width. We can derive the expression for fringe width. We can derive the expression for fringe width. Now, the fringe width means, what is meant by fringe width? Yes, sir. What is meant by fringe width? Simple. The fringe width means the distance between the two successive bright fringes. Yes, the distance between the two successive bright fringes or the distance between the two successive dark fringes, we are going to call it as what? Fringe width. Yeah. The distance between the two successive bright fringes or two successive dark fringes, we are going to call it as what? Fringe width. Yes, this is about fringe width. There are define fringe width and derive the expression for fringe width. Yes, derive the expression for fringe width. The definition will be simple. The distance between the two successive bright fringes or the distance between the two successive dark fringes, we are going to call it as what? Fringe width. Okay, this one you have to remember. Next, in Young's double slit experiment, we are going to mention path difference. Yes, we are going to mention the path difference. We have to get the bright fringes, means that will be constructive interference. Constructive interference means what? Maximum intensity. Maximum intensity. For constructive interference, maximum intensity means what? The path difference will be n lambda. Just we have to remember this. Till right, we have to remember this one. You are going to use in my derivation. Constructive interference, maximum intensity, path difference, I am going to write delta. The path difference means that will be n lambda. Here n value is going to vary from 0, 1, 2, 3, etc. Same way for destructive interference. For destructive interference, minimum intensity, the path difference again I am going to write delta. Yes, sir. Destructive interference, minimum intensity, path difference will be delta. Now the path difference delta will be 2n minus 1 into lambda by 2. This is for what? Destructive interference. Here also n value is varies from 1, 2, 3, etc. Okay, here for destructive interference, the path difference we can take 2n minus 1 into lambda by 2, or also we can take 2n plus 1 into lambda by 2. When I am going to take n plus 1 into lambda by 2 means here n value is going to vary from 0, 1, 2, 3, etc. So we can take 2n minus 1. When you are going to take 2n minus 1, n value is from 1, 2, 3, etc. 2n plus 1 means n value is going to vary from 0, 1, 2, 3, etc. This one I am going to use in my derivation. Keep in mind, this is the path difference for constructive interference. This is the path difference for destructive interference. Clear? Now, this is the basic thing I am going to use in my derivation. Now, first we can come to the diagram. When you have to derive the expression for fringe width means, first we can take the diagram. We have to get the interference pattern on the screen means first what we need? We need the coherent sources. So we need two coherent sources. That's why when I need two coherent sources means first I am going to take two coherent sources. S1 and S2. Two coherent sources S1 and S2. S1 and S2 are the two coherent sources. The distance between the two coherent sources, or distance between the two slits, distance between the two slits, what I am going to take small d. That's what I am going to take small d. Now, the distance from slit to the screen, I am going to take capital D. Distance from slits to screen. Distance from slits to screen, that is what? Capital D. Distance from slit to screen, that will be what? Capital D. From first slit to screen, I am going to mark Q. From second slit to screen, this mark point I am going to mark R. Then I am going to mark R. Now, what will happen? At the center of the screen, at the center of the screen, we will get what? Bright fringe. At the center of the screen, we will get the bright fringe. Means I am going to write O. At the center of the screen, I will get the bright fringe. That is what? O. Why I am going to get the center of the screen? It will be bright fringe. Means that will be simple. The distance from S1O is equal to S2O. When S1O is equal to S2O, the path difference delta will be 0. When path difference delta will be 0, the phase difference is also 0. If there is constant phase, you will get bright fringe. Yes, I will get the bright fringe. Okay, that's what this one we already we know in Ames demonstrate experiment. Whenever the constant phase difference, we will get the bright fringes, constant interference. When there in phase, we will get the dark fringes. Now, this is about what? Diagram. Keep in mind, I am going to take two slits, means two coherent sources, S1 and S2, separated by distance small d. Let's screen. I am going to place a distance capital D from the slits. Now, at the center of the screen, I am going to the bright fringe. Now, I am going to mark the S1Q from the slit 1 to screen, slit 2 to screen. Now I am going to take, let P be a point. Let P be a point. Now let P be a point from here to here. I am going to mark. Now let P be a point at a phase difference. Yes, at a path difference. Sorry. Let P be a point is of path difference. I am going to write the path difference delta is equal to the path difference delta is equal to what? Path difference from P from two slits what? S2P minus S1P. This one I am going to write equation 1. The path difference delta will be what? S2P minus S1P. Now here one more thing. Wait. Now, what I am going to take means the distance from center of the screen to point P, I am going to take X. Distance from center of the screen to point P, what I am going to take distance will be X. Okay. Now, this distance will be D means this QR is also what? D. QR is also D. Now, here we can write here we can write S1 S2 means S1 S2 means what? QR is what? D. When QR is D, OQ and OR is what? QR is D, no? OQ and OR is what? D by 2, half of D. OQ and OR is D by 2. Same way, S1Q, S2Q is what? D. S1Q and S2Q is what? D. S1Q, S2R is what? Capital D. S1Q, S2R is equal to what? Capital D. Next, OP is what? X. Yes or no? Distance OP is what? X. OP will be X. Yeah? That's Okay. Now let P be a point of a phase difference delta. Phase difference delta is what? S2P minus S1P. S2P minus S1P. This one I am going to take equation 1. This one I am going to take equation 1. Now I have to find out what is the value of S2P and what is the value of S1P. Yes, we have to find out S2P and S1. Clear? Now I have to find out the value of S2P means I am going to take from triangle. What triangle I am going to take? S2 or P triangle I am going to take. S2 or P. From triangle S2 or P. From triangle S2 or P. We can apply the Pythagoras theorem. This is going to become right angle triangle now. Yes or no? S2 or P. Okay, and I am going to apply the Pythagoras theorem. Hypotenuse side S2P whole square. S2P square is equal to what? S2R. S2P square is equal to S2R. S2R square plus PR square. PR square. Yes sir. Now S2P square is equal to S2R means what? Capital D. Keep in mind. S2R means what? Capital D square. Next, PR square. PR means what? PO plus OR. PO is what? PO is what? X. OR is what? D by 2. Means that will be PR will be X plus D by 2 whole square. Keep in mind. Yes or no? S2R is capital D. S2R is capital D. Yes. PR means what? OP plus OR. OP plus OR. OP means X. OR means D by 2. X plus D by 2 whole square. Now S2P square is equal to D square plus X square. A plus B whole square expansion. A plus B whole square expansion. X square plus D square by 4 plus 2AB means 2XD by 2. 2XD by 2. This is what? S2P square. This one S2P square. Same way, now I already found out S2P value. Later I will get the S2P value. Now I want S1P. That's why I am going to take from triangle S1PQ. From triangle S1PQ. 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 S1P square is equal to S1P square is equal to S1Q square. S1Q square plus PQ square. S1Q square plus PQ square. PQ square. Now S1P square is equal to S1Q means what? Capital D. S1Q means what? Capital D square. Now PQ. Yes, PQ. OP is X. I want only PQ. That's why OP minus OQ. Yes, sir. OP minus OQ. OP minus OQ means OP is X. OQ is D by 2. That's why it will be X minus D by 2 whole square. X minus D by 2. Again, S1P square is equal to D square plus X minus D whole square. Just X minus D whole square means A minus B whole square. A square plus B square minus 2AB means X square plus D square by 4 minus 2AB no, minus 2XD divided by minus 2XD divided by 2. Clear? Now, I want to keep in mind, we want only S2P minus S1P. That's why I am going to subtract here S2P square minus S1P square. S2P square minus S1P square. First I am going to write S2P values. D square plus X square plus D square by 4. D square by 4 plus this 2 will cancel. Remaining is what? XD plus XD. Again minus S1P square. Minus S1P square. Minus into plus. Minus D square. Plus into minus. Minus X square. Plus into minus. Minus D by 4. This again, this minus cancel. This will be minus 60. Sorry, 2 to cancel. Minus 60. Again minus into minus plus 60. Plus 60. Now plus D square minus D square plus X square minus X square plus D by 4 minus D by 4 will be cancelled. Okay. Now this will be XD plus XD is what? 2XD. XD plus XD is what? 2XD. Clear? Listen. XD plus XD, 2XD. This S2P square minus S1P square. S2P square minus S1P square means that will be what? A square minus B square. Listen. A square minus B square, what you are going to write? A plus B into A minus B. A plus B into A minus B. This one I am going to write S2P plus S1P into S2P minus S1P. Like that we can write now A plus B into A minus B. Same way I am going to write now. Same way I am going to write now S2P plus S1P into S2P minus S1P. S2P plus S1P into S2P minus S1P. Now we want the value what? S2P minus S1P. Yes, no, S2P minus S1P. That's why I am going to keep S2P minus S1P is equal to 2XD divided by, yes, no, 2XD divided by S2P plus S1P. S2P plus S1P. This is what? Path difference. Here I am going to take one assumption. If P is close to O. If P is close to O. When P is close to O, listen, when P is close to O, what will become? S1P is approximately equal to S2P is approximately equal to what? Capital D. Yes, sir. When P will come to O, nearly P come to O, S1P is equal to S2P is equal to capital D. The above equation will become S2P minus S1P. S2P minus S1P is equal to 2XD divided by D plus D means what? 2D. DD will cancel. That will be what? XD divided by capital D. This is XD divided by capital D. This is S2P minus S1P means what? Path difference delta. This is the path difference delta. Clear? This is the path difference delta. Clear? Clear? This one I am going to take equation 2. I am going to take. The path difference delta it will be what? XD divided by D. This is XD divided by D. Clear? Clear? Yes, so now I am going to drop. So still more derivation is there. Now I am going to drop. I will go for the next steps. Clear? Yes, sir. Just simple. At the center of the screen we will get a break fringe of cause 0 phase difference. Now let P be a point of phase difference. Sorry, 0 phase difference and 0 path difference. Let P be a point at a path difference of delta will be what? S2P minus S1P. I have to find out the S2P value means I am going to take the triangle S2RP. I am going to find the S1P value means I am going to take the triangle S1QP. S1QP or S1PQ. and I am going to get the values of path difference S2P minus S1. This one S2P minus S1P. Now, clear? This one remaining thing I am going to rub now. Now, already I told for nth bright fringe, what is the path difference? N lambda. Yes, now for nth bright fringe, you will get the path difference will be what? N lambda. That one I am going to write here. Delta, it will be path difference hd divided by capital D. This one equation 2 I am going to take. So, now, already I told for bright fringe the path difference will be what? N lambda. This one N lambda. For bright fringe the path difference delta is equal to N lambda. The path difference delta is equal to N lambda. Here N value varies from what? 1 to 0, 1 to 3, x. 0, 1, 2, 3, etc. Yes, and N value is going to vary from 0, 1, 2, 3, etc. Now, distance of when you are going to equate this path difference and this path difference, what you will get? You will get the distance of nth bright fringe from the center. This one will get the distance from nth bright fringe from the center. That's why this equation I am going to take equation 3. When I am going to equate 2 and 3. When I am going to equate equation 2 and 3, what will happen? N lambda is equal to x small d divided by capital D. Now x is equal to n lambda d divided by small d. This is the distance of n bright fringe. This is the distance of n bright fringe. This is the distance of n bright fringe. Distance of n bright fringe. Now, fringe width means what? The distance between two successive. Yes, the distance between two successive bright fringe or two successive dark fringe. First I will go for bright fringe, next I will take to dark fringe also. Now the distance between two successive bright fringes or two successive bright fringe. This is for n bright fringe. Next bright fringe means what? N plus 1. That's why you have n bright fringe there. That's n plus 1. Yes, n plus 1. Now this will be n plus 1 is what? N plus 1 into lambda d divided by small d. Lambda d divided by small d. Now, the distance between two successive is what? N x n plus 1 minus x. That's the distance. These distances. Now, what will become? When I am going to subtract n plus 1 into lambda d divided by small d minus n lambda d divided by small d. When I am going to substitute, what I will get? N lambda d divided by small d plus lambda d divided by small d minus n lambda d divided by small d. When I am going to plus, so minus will be cancelled. This xn plus 1 minus xn means that one I am going to write beta. Beta is the fringe width. Beta is the fringe width. That will be what? Lambda d divided by small d. Lambda d divided by small d. Clear? This is what? Fringe width. The distance between the two successive bright fringe we got. That's why we got the distance between two successive bright fringes. That's why distance between the two successive bright fringes. Clear? That's why already we know path difference. Delta will be S2P minus S1P. That path difference will be extract SD divided by capital D we got. That means both the path difference for bright fringes, n bright fringe path difference. And this path difference I am going to equate, we will get after that this is n bright fringe, n plus 1 bright fringe, and I am going to take the difference with this. Clear? This is for bright fringes. Same way for dark fringe. For dark fringe, what is the expression path difference already I told? 2n minus 1 into lambda by 2. Where n value varies from 1, 2, 3, etc. 2n minus 1 into lambda by 2. Now distance for nth bright fringe ಇಲ್ಲಿ nth bright fringe, here will be nth dark fringe means I am going to take equation 4 where I am going to equate equation 2 and 3. When I am going to equate equation 2 and 3, what will happen? 2n minus 1 into lambda by 2 is equal to xd divided by capital D. Now x is equal to 2n minus 1 into lambda capital D divided by small d. This is what? Distance of nth dark fringe. This is the distance of nth dark fringe. Clear? This is the distance of nth dark fringe. Now, two successive. This is nth dark fringe. Now n plus 1th dark fringe. N plus 1th dark fringe. N plus 1th dark fringe means what? Here in n plus we can straight write what? N plus 1. What will become? 2 into n plus 1 minus 1 into lambda d divided by small d. Xn plus 1 means what will get? 2n plus 2 minus 1 means what? Plus 1. 2n plus 1 into lambda d divided by small d. 2n plus 1 into lambda d divided by small d. Now, distance between the two successive dark means n plus 1th dark and nth dark means what? Xn plus 1 minus xn. Xn plus 1 minus xn. 2n plus, I am going to multiply directly. 2n plus 1 lambda d divided by small d. 2n plus 1 lambda d divided by small d. Okay. Right from here. Xn plus 1 minus xn. Xn plus 1 minus xn. I am going to multiply lambda d here itself. 2n into lambda d means 2n. Lambda d divided by small d. Again 1 into lambda d means plus lambda d divided by small d. Minus this one 2n into minus 2n into lambda d divided by d. Lambda d divided by d. This is what? 2d. Sorry. This is 2n minus 1 into lambda by 2. No? Now x is equal to this lambda d divided by 2d. This 2 here. 2 here also. Here also. 2d. 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 Now, minus 1 into lambda d divided by 2d. Minus means we will get what? Plus lambda d divided by 2d. Lambda d divided by 2d. Now plus 2n minus 2n will be cancelled. Now plus lambda d divided by 2d plus lambda d divided by 2d. 2 lambda d divided by 2d. Now this is what? 2 lambda d divided by 2d. Now 2 will cancel. Yes, 2 will cancel. Now this distance, the distance between the two successive dark fringes, distance between two successive dark fringes, what we call that is only fringe width beta. This is fringe width beta. Now fringe width beta is equal to, yes, fringe width beta is equal to lambda d divided by small d. This one taking dark fringes, this one we are taking in bright fringes. In exam, you can do any one. Yes, sir. Both the for bright fringes and dark fringes is not necessary. After deriving this one path distance delta is equal to xt divided by capital D, you can do only bright fringe or only dark fringe. Any one is enough. Okay. For showing distance between the two successive bright fringes and distance between the two successive dark fringes will be same and derive both. Clear? You can do any one. Clear? Yes, this is what fringe width derivation. Yes, fringe width derivation. The distance between two successive bright fringes or the distance between the two successive dark fringes. Yes, the distance between the two successive In your exam, they will ask 2 marks. What are the factors on which fringe width depends? Yes, what are the factors on which fringe width depends? Simple, based on the formula. Fringe width depends on wavelength of the light. What the coherent sources we are going to use now? The wavelength of the light. Next, distance between the slit and screen. Yes, distance between the slit and screen, and distance between the two slits. Yes, distance between the two slits. Okay, these are the factors. Now, they will ask how the fringe width depends on wavelength. Yes, how the fringe width depends on wavelength. Means fringe width is directly proportional to what? Wavelength. Means wavelength increases, width of the fringes also increases. Yes, width of the fringes also increases. Same way. The distance between the slit and screen increases, again the fringe width increases. Means the capital D increases, fringe width also increases. Means the distance between the slit and screen increases, what will happen? The fringe width also increases. Same way, when the distance between the two slits, small d, distance between the two slits, small d increases, what will happen? The fringe width decreases. Yes, the fringe width decreases. In the last class itself I told, when the slits are widened, yes, the slits are widened, the fringes are gradually disappears. Yes, the fringes are gradually disappears.